Additional psychophysical tests of the V1 Saliency Hypothesis. Part 1. The feature blind auction. Maximum rather than summation over features. Let's recall that VSH states that the highest V1 response to each visual location represents the saliency or bidding value for exogenous attentional selection at that location. This hypothesis has received a strong support by having its prediction of an unknown but strong saliency effect by an ocular singleton confirmed experimentally. Because this hypothesis is precise, and because we have quite a lot of knowledge about the physiological properties of V1, VSH can provide additional predictions on visual saliency behavior. So let's now proceed to look at some of them and test them psychophysically. One prediction comes from this VSH rule that it is the highest V1 firing rate, not the average or summation of firing rates of neurons for each location that determines saliency. So therefore, a prediction is that saliency is by the maximum V1 response, not a summation of V1 responses for each location, when all these responses could be responses to different visual input features at that location. Let's have a concrete example. This is a visual input made of two neighboring textures of bars. As usual, we show just a portion of a larger area of visual inputs, with additional texture bars extending continuously beyond this portion shown here. With this visual input, the V1 responses are visualized here. The stronger responses are visualized by thicker bars. So the responses to the texture border bars are stronger, since each border bar has fewer iso-orientation neighbors to exert iso-orientation suppression on it. For example, for this bar at the texture border, only these neighbors share the same orientation with itself, but not any neighbors to its right. However, for this texture bar away from the texture border, almost twice as many neighbors are sharing the same orientation. So the neurons responding to the texture border bars suffer less from iso-orientation suppression. Therefore, these are the maximum responses to individual texture element locations for the saliency map, according to VSH. This makes the texture border more salient to attract attention, and this helps texture segmentation to separate this whole pattern into two different texture regions. Now let's look at a second visual input pattern made of alternating horizontal bars and vertical bars in a checkerboard pattern. For each bar, this one for example, only half of its neighbors share the same orientation with itself. So the number of iso-orientation neighbors is similar to that for a texture border bar here to the left, and therefore each bar evokes a response that's comparable to the response to a texture border bar here. And this will be the resulting response levels to bid for visual selection. Since all locations bid equally for selection, no location can attract attention more strongly than another one. Let's call this visual input pattern A and call this one B, and we superpose them on top of each other to make this composite pattern C. Then the V1 responses will come from these two populations of neural responses. One population of neurons responding to the left and right tilted oblique bars in the texture input A, and the second population responding to the horizontal and vertical bars in the texture input B. Let's say for concreteness that the response to each non-border bar is roughly 5, and to each of the border bars is roughly 10, and a similar response level 10 for each of these bars in texture pattern B, and as a result, the maximum response to each location in a composite pattern is also 10, whether it's at the texture border location or not. And this gives this bidding or saliency map for visual selection. Then no location in a composite texture is salient. And this would make it difficult to do texture segmentation in this composite texture. And this does seem to be the case. For segmenting the left texture region from the right texture region in the composite texture C, the input component texture A is thus relevant, but the component texture B is thus irrelevant. So therefore, by VISH, the irrelevant component B interferes with texture segmentation. If saliency is determined by summation over neural responses at each visual location, then the response to each border location will be 20. And the response to a non-border location will be 15. And this would make the texture border locations still the most salient to make the texture segmentation easy. The predictions can be easily tested psychophysically. We show the texture pattern A or the composite texture pattern C to observers, and they have to locate the texture border and, as quickly as possible, press a button to report where the border is. So if the border is salient that attracts their attention, they can do this task quite quickly. We look at their reaction time, RT, to report the border location. And these are the RT data from 4 observers. When observers see the simpler pattern A, their reaction time is typically half a second or shorter. The task is very easy because the texture border is very salient. But the segmentation of the composite texture takes typically more than a whole second, suggesting that the texture border is not salient. This confirms the VISH prediction. Even when observers knew ahead of time that the horizontal and vertical bars were irrelevant, they could not prevent their interference to their segmentation task. Just to give an idea of how difficult it is to segment this composite texture C, which requires a reaction time of typically more than a second, the reaction time to locate the border in this texture is about 650 milliseconds. Here, the texture border is not as salient as the texture border in the texture above because the orientation contrast at the border is only 20 degrees. Meanwhile, to segment this texture is slightly easier, with a reaction time around 600 milliseconds. Although the texture bars are not uniformly oriented in each region, the orientation contrast at the border is large, making the segmentation sufficiently easy. Each texture bar here has an orientation that matches the average orientation of the 2 intersecting bars at the corresponding location in this composite texture C. So these findings support VISH's idea that saliency is determined by a maximum rule, not a summation rule that is suggested by traditional models for bottom-up saliency.